I've always been fascinated by dashboards and control panels, and anything with gauges, knobs, lights, dials have always kind of seemed interesting to me. I don't know if it's the sense of controlling something or the sense of so much information perhaps at your fingertips, but I am still the guy that every time I get on an airplane, I peek into the cockpit to see what's up there. And quite frankly, to a guy that doesn't know how to fly an airplane, that can be pretty intimidating. And I think the same thing holds for people making roughness measurements. The person that's making a roughness measurement often wants to simply trace a stylus over a surface and get some results or see some picture of that surface, but they are confronted with a gauge or with software with a bunch of settings, much like the airplane cockpit, that don't quite seem to make sense. So let's make sense of the settings inside your measurement system today. It can be intimidating with lots of options, but really there are only a few things that really matter. So let's break it down into the measurement of a surface and what we're going to look for in those settings. Now, a surface is going to have lots of different wavelengths in it. There are going to be very short wavelengths, maybe molecules and longer wavelengths, and then we get into the roughness, and then maybe waviness is longer wavelengths, and perhaps even form or straightness as very long wavelengths. Wavelengths are represented by the Greek letter lambda in most cases, and we need to tell our roughness gauge that we are making a roughness measurement. So we're going to have to tell the gauge which wavelengths we care about. Now, the primary setting for this is going to be a cutoff wavelength. Lambda for wavelength, C for cutoff, and in most cases, most machined surfaces, you'll need to look around in your menu and find a roughness cutoff, a lambda C, or a cutoff wavelength, and it's typically going to be 0.8 millimeters in normal machining, grinding, turning, honing, those kinds of things. 0.8 millimeters is the most common. Now, we're not going to go into alternatives here, but if you need help choosing the right one in weird cases, we are happy to help at Digital Metrology. Now, in imperial units, that's going to be 30 thousandths of an inch. So this is the most common separator between roughness and waviness, and we need to find a setting in the software to choose this wavelength. Now, the gauge may also have a filter type that goes with that wavelength. In most cases, a Gaussian filter is going to work for you. However, if you're doing things like plateauing or dealing with porous surfaces, you might want to check out the Notepad video on robust filtering. Now, we're also going to remove the tiny wavelengths, things like the spacing of molecules or the spacings that aren't really related to our machining. That is done with a short filter at a short filter wavelength, lambda for wavelength, S for short, and this is designated two different ways in your instrument software. Sometimes your instrument will show it as a bandwidth, saying that the short limit is 300 times smaller than the roughness cutoff. In other systems, it will be reported as micrometers, 2.5 micrometers, or perhaps 100 microinches. Or in other systems, you might see this as 0.0025 millimeters, or 0.0001 100 millionths of an inch. So we have to tell the measuring system which wavelengths we care about. It starts with the roughness cutoff, and then we have to also specify the short filter cutoff wavelength to designate roughness. Now, that's the most important setting. The next most important setting is going to be the length over which we are going to do our calculations. How much surface length do we care about? Now, the surface length is interesting because we can designate this two different ways. One way that most portable gauges will designate the evaluation length. Now, I'm going to be specific here. The evaluation length is the amount that we're going to calculate over. The gauge may actually measure more than that to throw some points away due to filtering. So the evaluation may be different than the tracing length. The tracing length could have some extra. Many of our portable gauges choose the evaluation length based on the cutoff wavelength. The evaluation length is typically 5 times the cutoff wavelength. So your roughness gauge is going to have a setting in it, and sometimes they will call this setting N, the number of samples, and the number of samples means the number of cutoffs that we're actually going to measure. 5 times the cutoff wavelength. In the case of metric, that would be 4 millimeters. Now, a quick note on this. Your gauge may default to 5, but it may trace 6 or 7 to have room to throw away the ends due to the math, not due to the speed or velocity or speeding up or slowing down. This is fine in many cases. 5 times the cutoff wavelength is adequate. But what if we have something like a plateaued surface and 4 millimeters only gives us a little piece? Sometimes 5 isn't enough, and it's wise to choose longer so we can get more averaging and maybe see more of the valleys that matter. So don't lock your mind in on 5, especially with plateauing where we have features that are far apart. Now, we don't necessarily need 5. We can always go less and check out the Notepad video on short surfaces. But for now, the primary things we care about are the filter wavelengths, so we know what we mean by roughness, and the length that we're going to measure. Some systems even allow us to directly type in a length in millimeters or inches, but we're going to need to control waves, and we need to control the length that we're going to calculate over. To find out more about your roughness system, or to perhaps navigate those menus a little better, be sure to reach out to us at digitalmetrology.com.